Today's lesson was about finding limits graphically and numerically. So we estimated a limit using a numerical or graphical approach. So I'm going to teach you how to use a table to help you find a limit and how to use a graph to help you find a limit. We're going to learn different ways that the limit can fail to exist. And we're not studying formal definition of a limit until later, but that's coming up. Okay, an introduction to limits. Suppose you were asked to sketch the graph of the function f given by this function, f of x equals x to the third minus 1 over x minus 1. But x itself cannot equal 1 because that would make it undefined. So, how would you know what happens to this graph as it approaches that undefined value of 1? Well, you would need to use a graphing calculator to find the values of the function for given x values that are close to 1. To do this, we're going to go to this link, desmos.com/graphing, to help us determine the limit of this function as x approaches 1. Okay, so now I'm going to go over here to Desmos graphing calculator to show you how to do this. So first, we're going to click in the box and we're going to type the function. And the function is y equals, I have to put parentheses, x to the third, and to make that exponent, you press shift and 6. And then to get out of it, you press the right arrow key, then minus 1. We're going to close the parentheses, and then divided by x minus 1. And I've typed on your notes page exactly how to type this in. Then after that, we're going to press enter. So it has graphed it for you. Now we're going to click on the box where our equation was typed. So we're going to click on this box, and we're going to click this gear up here. And then we're going to click the table. Now, as you can see, we have this lovely table here that we give an x, it goes into the function, and the answer pops out. So because we want to know what happens to this function as x approaches 1, we're going to use some numbers for x that are really close to 1. So for instance, 0.9, and then we're going to press enter, 0.99, enter, 0.999, enter, 1 is undefined, 1.0001, 1.001, and 1.01. Now, we don't care about the rest of this below this table, so if it bothers you, you can delete it all, but we're going to just ignore it. Okay, so what we care about is what happens as x approaches 1. Well, as you can see from this value, it looks like it's getting closer and closer to 3 because it says 2.997. And from this other side, it looks like it's getting closer and closer to 3 because this says 3.0003. Okay, so because even though it's undefined at 1 itself, we check on both sides of 1, like something less than that and something more than that, and we can see that it's approaching 3. So we would go back to our notes here. It says, notice what the y value is approaching as our x gets closer and closer to 1. It looks like we are getting closer and closer to 3 as we approach the x value of 1. This means our limit is 3. And the mathematical way of writing that, our limit is 3 as x approaches 1 is like this. So this says the limit as x approaches 1 of f of x is equal to 3. So the process we just went through using a table to find a limit is the informal definition of limit. Okay, so we're going to keep trying this. We're going to use Desmos again, and now we're going to type in this function. So we're typing in this function right here. So we're going to type y equals, so you can click the X on this, we're done with this. Click in the box, y equals x divided by, then you want parentheses. For square root, we're going to type SQRT. We're going to have x plus 1. To get out from underneath the square root, we're going to press the right arrow key. then -1, and close up the parentheses, and then equals, or enter. Okay, so we got that typed in there. Now, we're going to click the box where we typed the function. We're going to click on the gear. We're going to click the table. And now, we want to find the limit as x approaches 0. So see, look back here. Find the limit as x approaches 0. So we want to type some numbers in that are close to 0. And I gave you those already in your table on your notes. So we're going to type these numbers. Okay, so again, we only care what happens above this line. We don't care about what's happening below where my little cursor is at right now. So as it gets closer and closer to 0 on this side or the left side, it looks like it's getting close to 2. The y value is getting close to 2. And as you approach it from the right side, it's also getting close to 2. So that means that our limit as x approaches 0 of this function is equal to 2. So if you were to write your answers in the box as to what happened, it would look something like this. Okay, and since, like I said, it's getting closer and closer to 2, you can say the limit is 2. Okay? Alright, so that's how you use Desmos and the table on Desmos to help you figure out what the limit of a function is. Now we're going to look at this piecewise function. This piecewise function says, find the limit of f of x, and it says it's 1 if x is not equal to 2, and it's 0 if x does equal 2. So if we're trying to find the limit, so let me type out here what we're trying to find. Find the limit as x approaches 2. Let me get this typed in there real quick. If my computer will cooperate. Okay, that's x approaches 2 of f of x. Okay, everything you pick that's not equal to 2. So for instance, 1.9 or 2.01. Okay, it's going to pop out a 1 for the value when you plug those in for the function. So as x gets closer and closer to 2, we can say that the limit is 1 because it's literally going to equal 1. It's literally going to equal 1 if it's not equal to 2. So if x is not equal to 2, the answer is going to be 1. And limits are just asking you what happens as you approach that value, not necessarily what happens exactly at that value. Because a lot of times functions are undefined at that exact value, which is why we're finding limits in the first place. Okay? So that was example 2. Now, on example 3, we're going to find limits from a graph. So this whole picture here is a function. It's a piecewise function. It's broken up into different pieces, and I'm going to tell you what each of these notations mean. Okay? So first one, I'm going to type for you here what it means. My font a little smaller. This means what is the y value as x approaches 0 from the left. Because anytime you have a minus sign, like this little exponent right here is a negative, that means we're approaching 0 from the left. I'm going to get my handy dandy pen now, and I'm going to show you. So approaches 0, here's the x-axis. Approaches 0 from the left means we're coming in from this direction. So we're following this part of the graph to this point right here when x equals 0. And I'm asking you, what is the y value of this point? Well, the y value of this point is 0, so that means that its limit is 0. Okay, so we're going to type that. Now, this next one, we're approaching it from the right because there's an exponent that's a little tiny plus sign. So that means, again, make my font smaller. What is the y value as x approaches 0 from the right? So again, we're going to look at this graph. I'm going to pick a different color so we can keep them straight. Okay, we're coming in to x equals 0 from the right. So that means we're coming in from the right side of x equals 0, because here's x equals 0. This part is to the left, this part's to the right. And the reason we're picking this branch of the graph is because it goes towards x equals 0. So right here is where it lands when x equals 0, and its y value is 2. So the limit as x approaches 0 from the right is 2. Oops, we're going to type that. Now, because as we come in from the left, it goes to 0. And as we come in from the right, it goes to 2. These are different values. So when x equals 0, the graph is approaching 2 different values. And that means the limit as x approaches 0 of the whole function itself does not exist because it's going to 2 different spots. So when there is no little exponent, that just means look at what's happening as you come in from the left and the right. And if they're approaching different values, that means the limit does not exist. Okay, so we're going to write the limit does not exist. So that's abbreviated DNE, does not exist. Okay. Now for part D, so let's see if we can erase these little marks here. For part D, it says, find the limit of f of x as x approaches 2 from the left. So approaches 2 from the left. So here's x equals 2. We want to approach it from the left. So left of x equals 2 is this branch. Okay, now since this is the left side and it's coming in here, this is where x equals 2. Its y value is negative 2. Okay, so see here, as you come in towards x equals 2, this is the point. Its y value is negative 2. So that's what we're going to type for part B, is negative 2. Okay, now, as we approach it from the right, because as you see this little plus sign exponent here, means now we're approaching 2 from the right. So we're approaching 2 from the right, so we're going to come in on this side. And when you get to x equals 2, what is the y value of this point? Well, it's 0. So for this part, we're going to say the limit is 0. Now, again, because as we approach x equals 2 from the left and from the right, it's going in different spots. That means the limit as x approaches 2 does not exist because it's going to 2 different spots. Okay. Now, the last ones here, we're approaching 4, first from the left and then from the right. So first, let's find where x equals 4. It's right here. Okay, so we need to see what happens as you come in from the left. Well, left towards x equals 4 is going to be this part of it. And when you get to x equals 4, it looks like the y value is 4. So that's what we're going to type for the answer. The limit as x approaches 4 from the left is 4. And then the limit as x approaches 4 from the right. So from the right, we're coming in from this way. And as you come in from the right, you get to this same point, and its y value is 4. So we're going to say that the limit as x approaches 4 from the right is also 4. Now this time, if you'll notice, my yellow and blue lines are going towards the same spot. This means that it's approaching the same thing from the left and from the right, which means that the limit as x approaches 4 is equal to this y value, which is 4. So if they approach the same thing from the right and from the left, it's just that number. Okay, so your homework will include using tables to help you find a limit on desmos.com/graphing, and then you'll have to find some of the limits from a graph. So the homework is a Google form, but those are the topics that it covers. So if you need any help, please let me know, and I hope it goes well. Bye.